can just take it off. Well, folks, let's get started. It's 11 o'clock. Welcome to the session on the Winter Weather Road Index. I always get that acronym mixed up. We have three great speakers here to talk about it. We have Kevin Griffin from our Central Maintenance Division, Jeff Williams from our Traffic Operations and Weather Operations in particular, and Cody Opperman, who works with Jeff. They've developed this really cool thing that allows us to measure our performance relative to the severity of a storm. And I think you'll find it exciting. I think you'll find that it's innovative and something that we can build upon to not only understand how we're doing, but let our customers know as well. Little housekeeping before we begin. This is a what I call a 4-credit class, so if you have a need for CEU credits, those are available, but we need to sign the rolls. So let's just keep these circulating throughout the session, because there may be people that come in that missed it the first time around. Other housekeeping item, if you need to get up and go to the bathroom, it's right through here, okay? So. Now you tell me. So just open the curtain, you're there. So with that, I'm going to turn the time over to Kevin, and I think he's going to be followed by Jeff and then Cody.
I can't stand behind a podium, you know that. All these Region 1 guys here to heckle me. Look at them. I have an opportunity as the Director of Maintenance for UDOT to go to AASHTO, go to WASHTO, go back to TRB, and see different things. And at one of the WASHTO SCOM meetings, which stands for Standing Committee on Maintenance, Idaho presented a version of this, which was very rudimentary in what they had done. And what they did is they got with a supplier of a specific type of device, a non-invasive sensor made by a company called Vaisala. And they paid Vaisala to implement this system for them and to produce a so-called performance measure for them for snow removal. And basically what they're using it for, it has one factor in it, and it tells them only after the storm how they perform. But I thought it was pretty cool. And so I went and talked to their head maintenance engineer, his name's Steve Spoor, and I said, would you mind if I stole that from you just to look at it? He said, sure. And that's one of the things that, AASHTO and WASHTO are about, is states sharing information so that we can make our processes better. So I bring this thing back, and I'm not the smartest guy in the room. Anyway, so I engaged the guys who are smart. So I contacted Jeff and Cody over at the TOC and our weather group and gave them this information and said, hey, currently right now with our snow and ice, how we measure performance, what do? Maintenance guy, what is it? 1 hour after the storm. So we click a box on condition of the roadway and what it looks like 1 hour after the storm is over. So does that tell us something? Yeah, it does. But does it take into account storm intensity, road temperatures, blowing snow, anything else? No, it doesn't. It just tells us the condition of the road 1 hour after the storm. So I gave this to the smart guys and said, take a look at this. Let's come up with some ideas of what we can do here as far as instrumenting our RWIS stations with non-invasive sensors. I don't want this to be proprietary to one company, because I guess the fees that Idaho pays to Vaisala every year is around $3 million, and I didn't want to do that. So we've built this thing from the ground up, and we've used numerous different sensors out there. Some require some different calibration than others. But currently right now, I think we have about 65 of our 90 RWIS stations with this capability. Now, I'm not going to show you how it works. I'm going to let them show you how this works. But as far as I understand, we are the first state in the nation that has a capability now for real-time condition assessment during a weather event of how our roads look. So whether they're wet, whether they got slush, whether they're snow-packed, and basing that into a grip factor. And then this afternoon, you all need to go to the AVL piece. We put GPS in all of our trucks because all this plays in together for the future for UDOT. But so I am brief, and I'm going to turn the mic over to Jeff and kind of let him explain what these guys did with this idea and where we've gone with it. Yeah, Gordy? First time what?
I'm not as slick as Kevin here, so I'm going to put it up here. You'll have to bear with me. I've been battling a cold all week, and so you might hear some coughing and whatnot throughout the presentation. But I wanted to start off with giving a quick overview of the weather program. I think a lot of you guys are familiar with it, but just in case you're not, we have a road weather operations group focused strictly on operations. Largely, the biggest client for them is the maintenance crews. Is there, maybe just turn a little closer? Okay. All right. Is this better? All right. So our operations group is focused strictly on, or the biggest client is the maintenance crews, and there's over 5,000 interactions that go on between the maintenance crews and the weather forecasters, which is fantastic. In fact, we would like to have even more. The travel weather information is focused on public information, and one of the main goals that we're trying to do is trying to get everyone on the same page with the storm. So we work with the National Weather Service to try to get a unified message out to the public and out to the media what we expect the storm impacts to be, because 6 inches of snow on the grass doesn't mean that the road's going to be bad necessarily. So we want to make sure that the media has an understanding of what we expect the road conditions to be with the storm system. And then we have the RWIS stations, about 95. As Kevin said, we're around 65-ish that are compatible with our index that we'll talk about. And then we have research and development. A large part of that is the Winter Road Weather Index and also the Snow and Ice Performance Measure. Cody Opperman's worked a lot on this. We're looking at a couple other factors too. There's multiple projects that we're working on, one of which is actually we're installing soil moisture sensors, and we're trying to identify whether or not the soil is transportable or not. So we want to get a better blowing dust forecast out there for the public and also for your crews out there. But one thing I have noted on here is the Utah strategic goals. So you see down below how they apply, and I want to talk a little bit more about that in the next slide. So this is a slide I got from American Meteorological Society, and they talk about all the weather phenomenon that's out there and what are the fatalities related to this phenomenon each year. And as you can see, you hear about hurricanes and tornadoes all the time, but really it's road weather accidents that cause most of the fatalities out there when it comes to winter weather. So obviously what you guys do is very important out there, the maintenance crews out there. So taking it more down to the UDOT level on mobility, this is looking at a travel time index. So those of you not familiar with it, it's a value of 1 indicates that you're traveling at the posted speed limit. So as we know, people tend to drive a little bit faster than the posted speed limits. Thus, you see some of them around 0.9. However, you can see there's some outliers there about 1.1 and above. And this is looking at the system across the Wasatch Front, so a good 80% plus of the population. So when we took a closer look at those outliers, 19 of the 20 top events were weather-related events. They cause a significant impact to mobility, as you guys know. One thing I want to point out is the one on the far right. That's on June 17, 2014. We actually had road snow on Parleys. So you can get road snow even into June, and that one did cause an impact up there as well. And so what is the dollar figure that's associated with loss of mobility like this? And so I found a study that says for a 24-hour statewide Utah snowstorm that there's $66 million of economic impact. So even a small difference that we can make on the roads will equate to quite a bit of money. And of course, a lot of that's in taxes coming back to support us again. So there's a big economic impact to snowstorms out there. So, this was when Kevin approached us and told us about Idaho, and he just said, what can we do to really, see how well we're performing out there. I mean, I already know that UDOT does a fantastic job with the roads, but how do we really prove this? And so we really needed to get a measure or handle on the weather on the road. And so we did some research looking around the country. A lot of states use climate networks such as the National Weather Service. It's good quality data, however, it does not measure the road at all. It's just measuring snowfall on the grass and looking at temperatures overall. And it's useful, but we wanted to do a little bit better than that. And then Kevin pointed towards the Idaho, what Idaho was doing with ARWIS data. So we thought, oh yeah, that's a great source of information. So let's utilize that. But Idaho was initially focused on post-storm assessment. How fast are we recovering from the storm? We want to take a look and see how well are we doing within the storm system. And so that's when we turned to design this, that we really wanted something real time. We want to see how you're performing while the storm's occurring. And we also know from, I've been a transportation meteorologist for 10 plus years, and hearing from you guys, the maintenance crews in the field, snowfall rates is probably the number one factor you guys have to deal with. Go to example, that Parley's event, in June, we had snowfall rates of 2 inches an hour. It had no trouble overcoming the road. So snowfall rate is a critical thing. And then road temperatures, obviously the colder the road, the harder it is to mitigate, and the more performance salts you have to use and whatnot. So we want to make sure we compensated for that as well. Wet bulb temperature is something you're probably not familiar with. It's something that we're utilizing for blowing snow, freezing rain, and it helps us determine if it's wetter or a dry snowfall. And we did develop this in-house with Cody, and I'll talk about here real quickly what wet bulb temperature is. So basically it's the lowest temperature that can be reached by evaporating water into air. So it's essentially like a swamp cooler for simpler terms. So, on a hot, dry day, you sit behind that swamp cooler, and it's pretty cold air, but on a warm, humid day, it's not so cold behind that. And that really helps us determine the dryness of snow, whether or not that snow can be transported or not very easily. It can help us determine if there's freezing rain out there. Is there a difference between wet and snowfall or rain and snow levels? One thing that this does too is that you probably have seen out there where it's snowing and it's 45 degrees outside. You really think it should be rain, but it's that evaporative cooling and that dryness of the air that allows it to stay in the form of snow all the way to the ground. So there's a lot of useful things we can do with wet bulb, and we wanted to utilize this in our index. So the Winter Road Weather Index is what we first started with. We wanted to get a handle on the weather elements, all the elements that really impact a road. And so one thing that we were told from Kevin is that a good baseline is an inch per hour. We're trying to be designed as well as we can for an inch per hour snowfall rates. And so we started with that, but we wanted to compensate for, like I said, road temperatures and other factors, wind gusts, and we'll get into that here a little bit later. And then one thing we're doing too is we're taking the worst variables from the last 20 minutes, because every now and then we do get one observation that kind of goes off key, and we want to make sure that we account for that in our instrumentation. So I'm going to turn it over to Cody here. Cody worked heavily on the development of this, and he's going to talk a little bit more of the geeky, sciencey stuff here associated with how we developed this index, and turn over to Cody.
How many like charts and graphs? Because this is this part of the presentation. Yeah. So when we developed this algorithm, we took into account basically the major impacts that plows are having to face on the road. So what is the road condition? If it's a snow-covered road, obviously you got to plow that. What is the snowfall rate? What's the road temperature, blowing snow, and is there freezing rain? So I developed a specific way to calculate each different section of this index, and we add them all up, and then we get the Winter Road Weather Index. And I'll talk about each of these individually here in a second. But first I want to talk about the road instrumentation that UDOT uses. We've dabbled in a wide variety of these to see what works best for us. We've used what we call road puck. If you've ever seen these, they're about yay big, and they go flush with the surface of the road. And they can measure road condition, salinity of the road temperature, what the freezing temperature of the road is, what the solution is on the road. But since they're in the road, they take a lot of abuse. They get run over by cars, they get nicked by plows, and each time we do maintenance on that road, we got to rip it out and then reinstall it. And that's a lot of cost to do that. So we're trying to move over to these non-invasive sensors. Recently, this company Luft made a non-invasive sensor that we're going to test out this winter. It takes a lot of power. It's very heavy. We couldn't use it on all our stations, but we figured they were going to give it to us for free to check out this winter, so we were going to do that. But the main instruments that we use are this Vizsla, as Kevin mentioned, that Idaho uses ubiquitously. We have a few of these in the field, and then we have eyesights that we use. And if you've ever driven along and seen our weather stations, they'll be pointing at the road. They kind of look like cameras, but they're not. They're measuring road condition and road temperature and all that sort of thing. So they all report differently. They all kind of operate differently. But the main things that we want to try and get out is the condition. They can measure dry, wet, slush, frost, snow. And Idaho used the grip from the Vizsla sensors. And what the grip is basically is the coefficient of friction. So any guys taking basic physics course knows kind of what this is. If the value of the coefficient of friction is 0, then it's completely frictionless, it's frictionless. It's like totally ice, that sort of thing. A lot of your physics problems deal with no friction, so this is what this would mean. And a value of 1 indicates there's total friction. You're not going to be able to move on that road. So average values that both the eyesight and the Vizsla report for dry roads is a value about 0.8. And as the conditions deteriorate, that grip goes down. So, and I'll show that in a second here. So back to this equation, the road condition value that we calculate, based off the data quality from both Vizsla and the eyesight, we decided to go based off the road condition for the Vizsla sensors and use the grip for the eyesights. So when you have a snowy road, we calculate a road condition value of 1. So that's basically we're already at the baseline for what crews can keep up with. That road's already lost, so we give a value of 1. And then decreasing values for slush and wet roads. But with the eyesight, we get a wide range of grip values, which we found correlate to what the Vizsla is reporting via road conditions. So we determined that the eyesights, based off how they are functioning, that about a grip of 0.5 is about a wet road, and then less than that you get into slush and snow-covered values. It's not perfect science, but it works pretty well. So for a value of 0.5 grip, wet road corresponds to about a 0.5 in the road condition value, which correlates to what we're doing with the Vizsla sensors. And as that grip deteriorates, the road condition value goes up. So for snow, your grip's about 0.1, 0.2, and you have values about 1.1 or greater. And for slush, it's somewhere in the middle. So the next value is the snowfall rate value. And if anyone has dealt with measuring meteorology or looked at how you measure snowfall rate, it's one of the hardest things to measure. You can have different sizes of snowflakes, and that is very hard to determine how that's going to pile up to determine what the snowfall rate is. So in the past, the best way of doing this is using visibility sensors, and all of our RWIS that can calculate this currently have a visibility sensor. And to differentiate between fog, because obviously we don't want to say it's snowing really hard if there's just fog, these sensors can determine if it's precipitating. So if there's fog, but the sensor says it's not precipitating, then we know it's not snowing, so we can eliminate that. But basically, when visibility is less than 2 miles, we know, and as precipitation is occurring and temperatures are cold, we know it's snowing. Based off past research and Jeff's multiple years of looking at this sort of thing, we've kind of come up with this relationship, which says if the visibility is about 2 miles, your snowfall rate's about 1/4 inch an hour. Get out of your fly. Visibility is about 1 mile, then your snowfall rate's about 1/2 inch an hour, so on and so forth. When you get really low visibilities, then we got to cap at the snowfall rate. But we kind of make this estimate for the index. And as you can see, so because maintenance crews are expected to keep up with 1 inch an hour. If the snowfall rate is 1, then the snowfall rate value is 0. We don't want to add any value to that. You're already at that benchmark. But if it's snowing harder than that, then we add a positive value. And if it's snowing less than 1 inch an hour, then we add a negative value to that. We wanted to see, so we came up with these evaluations of the visibility and snowfall rate, but we really wanted to see exactly how well the sensor was working. And so we took several storms and several sites, so I got about 10 samples. We picked storms that were really cold because we didn't want to measure any snow that had melted over the course of a storm. We do have a little compaction of snow, but hopefully during cold storms that's kind of negligible. So what we did was, we took these 10 cold, big snowstorms. We have on some of these sites a snow depth sensor, which is sonic ranging sensor. So basically it's off the side of our weather station and it sends out a sonar ping, and it can measure how long it takes to get back to the sensor, and that's how it determines how much depth is what the depth of that snow is. And so for each of these storms, I took the max snow depth at the end of the storm, subtract the minimum snow depth at the beginning of the storm, determine how much snow fell during that storm, and then with the visibility estimates, we took So the RWIS stations report data every 10 minutes. So if at one time the visibility sensor is reporting 1 inch an hour of snow, then I divide that by 6 because we get 6 measures in an hour, and then add all that up, and we get basically how much snow should have fallen based off the visibility sensor. And if we compare the snow depth, what the snow depth said and what the visibility sensor said, we're within about 15 to 20%. And you can see our correlation is pretty good here with that. It seems kind of like a lot, but if you're considering 10 inches of snow and we're off by 15%, that's only 8.5 inches of snow or 11.5 inches of snow, which we're in the ballpark, and with when we're trying to evaluate how severe the storm is, we feel like the snowfall rate's a pretty good measure for determining how severe the storm is in regards to snowfall rate. So the next value going along is the road temperature value. It makes sense if the road gets colder, it's a lot harder to mitigate. So we have basically a fairly linear relationship. As the temperature gets colder, this road temperature value increases. And so we've been told, depends on who the shed is, what they do, but around 22 degrees, we've been told that they switch to a high performance salt. And so we kind of give a little more added value when temperatures are below 22 degrees. The next one is the blowing snow value, and as Jeff talked about, wet bulb temperature. When you have a really cold wet bulb temperature, you have it's a really dry snow, and it's much more easy to blow around, stick to the road, that sort of thing. So on this graph, there's a green line here on the bottom that increases with decreasing temperature. And then when you add wind to it, each of these blue lines are 1 mile per hour extra, so the value increases with increasing wind. We also know that ski resorts, when they're making snow, will only do it if the wet bulb temperature is less than 20 degrees. And that's because the snow is dry enough for them to be able to produce that snow. So we kind of use that as a demarcation between wet and dry snow. And so when it's less than 20 degrees, that value increases even more, below 20 degrees. So. And then when we were very first kind of evaluating the Winter Road Weather Index, we had a storm back in 2013, this freezing rain event. Raise your hand if you all remember this day, because it's pretty chaotic for just about all of you. Good thing I had that day off. We realized that the index probably wasn't as high as it should given what was going on out there. So it's kind of hard to actually determine freezing rain. When freezing rain occurs in Utah, this usually happens when we have an inversion. And most of the time in Utah, when we have a storm coming in, the inversion blows out, the air mixes out, the ground surface in the valley gets warm before the storm comes in. We don't really have to worry about freezing rain. But during this event, the inversion didn't mix out. So basically you had snow falling, you get to the Park City, nice warm layer during the inversion, it melts, and then it comes back into the valley, it's cold, and then the rain doesn't have enough time to freeze, but when it lands on the surface, then it freezes. So anyway, usually you can have a wide range of wet bulb temperatures and freezing rain events, but we're pretty confident that when the wet bulb temperature is warm, say above about 35 degrees, that we're pretty confident that's rain. And you can't do that with air temperature because you can have it snowing at 45 degrees. So wet bulb's a little more accurate in determining that. So for the extreme cases, when the wet bulb's really warm and the road temperature, and I didn't mention this before, but we use 33 instead of 32. Sounds a little counterintuitive, but there are some sensor error, like the road temperature is maybe like plus or minus 0.4 degrees that we want to account for, so we said 33 instead of 34. But anyway, when the road's cold and you have a high wet bulb temperature, we're pretty confident that that would be freezing rain, and so this is calculated. We give an arbitrary value. If we had more freezing rain events, I'd do more research into this, but for now we just wanted to give added value to the index. We only noticed this one other time, I think it was last year in Provo Canyon, where this triggered, but this is kind of rare. So, but we wanted to give, like I said, extra value to the index during this scenario. So the benefits of this first part is it represents the overall road weather conditions a traveler will face. So even if, say for instance, you have a wet road, so that equates to, if you recall, about 0.5 for the road condition value, but it's snowing really hard, then while the road is good, but it's snowing really hard, the traveler will still have kind of a hard time driving through that. But because we're using this, that value basically says how bad your driving conditions will be. So we could use this as a current conditions reporter, but I'm doing more research into that. Up to this point, all this stuff that we've developed won a Best of ITS America Award for Best New Innovative Practice, Sustainability in Transportation a few months ago. We won a fancy award. So we haven't even got to the cool part yet. I bored you with all the math. We're going to get to the stuff that's actually interesting. So anyway, this provided the foundation for the performance measure that Jeff's going to come back and talk about. And what we do is we take the index and we separate the weather elements with the road elements to evaluate how we're doing compared to the snow that's fallen, the storm that's occurring.
I'll try to wake you guys up after that boredom of the graphs and charts, but actually I do have a lot more graphs and charts coming, don't I? Anyways. So the snow and ice performance measure is something Kevin really wanted. We really want to see how well you guys are performing. I know you guys do a fantastic job on the roads out there, but we really want to see how well you're doing. So what we developed is a storm intensity index. So basically we're looking at atmospheric conditions and road temperature, and we compare that to the road condition at that given time. And so it's essentially kind of picking apart the road weather index that Cody talked about and we're evaluating. And so we still have the same benchmark, 1 inch per hour if the road's 32 degrees. However, if the road goes down to 22 degrees, we lowered that snowfall rate just because we know it's a lot harder to mitigate that snow if your road temperature is 22 degrees or 17 degrees. And then obviously we counted for blowing snow and freezing rain as well. So here's the expectations here. So I'm going to point you to the middle one here, the light to moderate snow. So it's 1/4 to 1 inch per hour snowfall rate, and the expectation is that the road will be slushy or partially snow covered. If that road is wet or dry, you're doing very well. If that road is snow covered, there's probably more work we need to do to get that road back up to our expectations. And like I said, we are still contributing with road temperature, blowing snow, and other factors. So this is our kind of Rubik's Cube. So the way the scoring kind of works is we have a green, yellow, red up here. Green, you're exceeding expectations based on the weather conditions that you're facing at that moment. Yellow, you're meeting the expectation. And red, obviously, we could do a little bit more probably to get that road back up to the acceptable road condition. So I'm going to focus on the middle again. So this is your about 1/4 to 1 inch per hour rate. So if your road is slushy here, you're meeting expectations. If your road is snow covered, that means that it's unacceptable, and if it's green, that means that you're exceeding expectations on that road. Note, though, if you're above 1 inch per hour, there's not a red unacceptable. We realize that it's more storm than we're designed to handle, and we shouldn't be really nicked for that. We really do think that this is a key thing because I know a lot of times the public cries out about why weren't the roads in better shape, but we all know it was really snowing hard. Now we have a way to prove that. We can say, yes, it was snowing that hard. It is unrealistic for us to keep up with the storm when it's 2 inches an hour or whatnot. So that's one key factor to this. So I'm going to start off with showing some graphs and charts again. These are a little more colorful than Cody's, but so what this is, we're looking at Boulder Summit, and I think you guys should probably know where Boulder Summit is. It's down in southern Utah. They don't get a lot of traffic. It's up about 9,800 feet in elevation. And so this is looking at storm intensity. So you can see the storm kicked up a little bit and dropped off, and then the storm really got intense there. And then it dropped off again here, and then little spurt, and then it kind of leveled off. The line you're seeing here is that winter maintenance baseline that we've been talking about. So when it's above this level, really, there's not much we can do. Even if we had, 2-3 times more trucks out there, we probably couldn't keep up with it, to be honest, with that kind of intensity. And so what I'm going to do is I'm going to throw the road grip on top of that. So this solid line is still the same storm intensity we've been talking about, but the dashed line there is the road grip sensor. So the road grip is actually quite good here, 0.8, and there's not much weather. It's a good situation. And then we go to the tail end of the storm. The snow drops off and the road grip goes up. That's a good situation too. But in here we got a performance issue, looks like. So we got the winter weather actually drops off quite a bit, and the road grip is actually still rather low at that. So when we took a closer look, we realized that's at night. They don't plow this road at night. So we really didn't want it to ding them basically just because of the overnight expectation. So basically everything that's in the overnight hours is acceptable because we don't have crews out at that time. So when we apply, So this is looking at the exact same storm, exact same area. Your solid line is your storm intensity. The color of this is evaluating that specific time based on the weather conditions that were given. And as you notice, above this maintenance line, there's no red. We're not getting dinged when the storm is very, very intense. So when we're looking at this a little closer, you can see, like this is acceptable, it's exceeding. When you see green and red here, that means we're not meeting expectation, and that's your overnight period. And so we wanted to apply a filter to that because really it's not fair to say it's unacceptable when we're not designed to plow at night. And what we're doing as well is we're summarizing, I don't know if I can do this, we're summarizing the event here. So 42% of the time, I think if I can see it right, or 41% of the time, the event was deemed unacceptable road conditions given the weather conditions you face. However, we'll apply a filter here in the next slide to the overnight period, and you can see that percentage drop down to 11 or 12% there. So quite a bit better. But another thing we realize is that this location is about 2 hours away from the maintenance station. So in the next slide here, we did apply a filter. And one thing I want to note, though, is that the winter weather conditions stayed about the same here. But you can see, though, once the crews got out there, all of a sudden you see your road condition improve throughout that time. So we are picking up on that improvement in the roads. And so when I apply that filter to that 2 hour lead time to get to that location, the overall score is actually really good for this location. In fact, only 1% of the time was it deemed that it didn't meet expectations based on the weather conditions. So I got another good example here. This is Big Cottonwood Canyon. If you guys remember, we had a really quiet winter. However, Christmas, we had a good storm come through. And in the Cottonwood Canyons, we had a good foot or two of snow that fell over a couple of day period. And you can see here that it was quite intense. And if you do see the red performance issue here, and once again, it's at night. We did realize that they don't plow during certain hours of the night. And so if we apply a filter to this, it's actually a really good situation again. The performance was actually quite good during the storm, even though it was a significant snowstorm. But one thing also that told us we're onto something here is the winter weather here stayed about the same intensity. However, you can see when the crews got out there about 5, 6 in the morning, the road conditions went from unacceptable to acceptable to even exceeding expectation at that time. So obviously we're seeing the improvement of the road and the performance when the plows are out there. So it kind of validated that we're onto something with this performance measure. And that's this next slide. We actually took the adjustment over the overnight period. It's pretty much good as you can do in that route. And I think that route is expected to have a high level of maintenance due to the ski areas up there. I'm going to turn this over to Cody just for this slide. This is something that Cody has worked on. We automatically define a storm system by our algorithm, and it's worked out quite well. I'll let Cody here talk about the details of it.
Okay. So instead of me having to go look at each storm and handpick exactly when a storm has started or ended at a site, we kind of developed some rules so that we'll talk about in a minute on the website that when we show you, we can pick up, like select a storm from a site and look at the data for that. So the rules are basically we want to know each event where we're expecting we're probably going to get about at least a ½ inch of snow on the roads, something that the plows are probably going to have to get out and take care of. So to do that, if you think about the snowfall rate value or how the storm intensity index goes, we kind of came up with these rules. So basically, the storm intensity index, which is like this line, this is just kind of an example. If it goes above 0.5 for at least an hour, so if you think about 0.5 is supposed to correlate with about a ½ inch of snow at 32 degrees with no other problems going on. So if you think about that, then we have a ½ inch every 10 minutes. I'm going to explain this. Basically, we're going to get at least a ½ inch of snow during that period. So if it's above that for an hour, then we're like, okay, this must be a storm that's occurring. If the storm intensity index dropped, maybe it stopped snowing for a 10-minute period, and then the storm came back in, then that value went back up. The storm is still continuing. And so say if the storm kept going up and up, and the way we identify the storm is it keeps going. Once the storm is over, there needs to be a 12-hour period where there is no weather for the storm to end. If there's other pieces of storm coming in, say 6 hours later, we still want to count that as the same storm. So this has to be 0, and then the end would be basically an hour after it reached 0 again. So in this example, 3 hours and 40 minutes after the start. We also, for basically mine purposes, that is kind of important for other purposes as well, but we want to also include the first hour before the storm so we can see what the data is going like. We'll show an example of what this looks like on the website, but basically the storm starts an hour before it gets above 0.5 and an hour after it comes back down below to 0 after being up at 0.5 for an hour.
So I'm going to show you here a prototype of what we expect a dashboard to look like. So this is more designed to be a statewide dashboard. So it's kind of hard. It's going to be really hard to see. But up here we actually have, you can pick the number of winter storms for that particular RWIS site. You can pick out the number of winter storm hours that you've dealt with throughout the winter season. You can see how the intensity compares to other sites. So we expect this to be a great way to see how winter weather evolved across the state throughout the winter. And then we'll have a statewide summary here that shows overall how are we doing, It could be that we want to stay in the acceptable range more than we do in the exceptional, The one thing we'll have too is we'll have, once we have several years worth of data, we can compare it to previous winters. We can see how it did compared to the averages. There's all kinds of things we can do, and this is the page that we think can get you basic information quickly. And we do have another page here that we designed as well. This is more looking at a particular RWIS site. So we have that same graph that you were showing earlier up here. And then you can put your cursor actually over the graph and get the camera image at that time, even if it was a year or two ago. You can take a look at the camera images and see, did it really verify at that time? Were the road conditions good? And we do have a summary of storms down here. So every time we have a storm event, you can go back and look, how did we do during that storm event? How did it evolve with time? And you can see that down here. And then up here we have current road conditions. And then we have, for that storm that you picked, you can get what was the lowest road temperature at that time, what was the highest road temperature, wind speeds, grip levels. There's all kinds of data here you can mine and look at and see if there's room for efficiencies to be gained by looking through this data. And we also have a summary here of the number of storms you had. And what we're doing on the side here is we're comparing to the statewide average. So If the number of storms compares the statewide average closely, it's probably a moderate level. We're trying to give you a sense, is this more than the statewide average or less than the statewide average? And in these various factors here. So there's a lot of benefits to this. You know, we believe that it's a great resource to optimize resources out there. We think we could be used for budget and planning. I talked about the public response. I think that's an important piece, is that the storm's hitting really hard. This will be a way to show that, hey, it's hitting hard at that time. We're doing our best we can. And then justify overtime and justify salt usage based on this weather data. And Central Maintenance has all kinds of statistics and data that we hope to compare this with as well and see what we can learn from that. And then RWIS stations, about 95 across the state there with the red dots. It's about 64, 65-ish or compatible with their index. Unfortunately, it takes the addition of a visibility sensor and a non-invasive road sensor. And unfortunately, they're two of the most expensive devices we have on the RWIS site. So we're still pushing forward. Kevin's been supporting us to upgrade these sites, and we'll continue to do so over the next few years. And one of the challenges we've had is that we have to be pretty close to the road. We have to achieve a 45-degree angle is ideal. We can go as low as 30 degrees on some installations, but it's a challenge trying to get these as close to the road as we can or the travel lane, but yet be out of the clear zone. So we've actually gone through an evaluation process this summer to figure out what is the best way to put these up near the road, and we want to make sure we get them high enough as well so snowplow activity doesn't interfere with their instruments and whatnot as well. So it is a challenge out there to get these exactly right, and honestly we're learning some things from Idaho and how they install theirs and how we can improve ours. So, and also we're trying to get bridges if we can, because bridges obviously freeze before the road does, and some situations you can't achieve that, other situations you can. So the future of it, you know, we like to expand the RWIS network, at least get one compatible site per RWIS or per maintenance shed. There will be a challenge trying to adapt to road classifications. We have, you know, obviously interstates, level 1 and level 2. We have a lot of great ideas on how to do that. Right now we're starting with the interstates, and then we'll work down to the lower ADT roads. Mobile weather observations. This is something with Blaine Leonard we're going to be playing with this winter. We're going to be outfitting about 5 or 6 different vehicles with mobile weather observations, and we're hopeful that this can help fill in the gaps. And what this mobile weather observations are designed to do is recalibrate as they go past an RWIS site to make sure that they're reading correctly. And so we're hopeful that this can fill in the gaps, and not just that RWIS site represents the performance. We're hoping to fill in those gaps, and I think we can be more complete with that. I don't think we'll do it with plows, because plows create so much environment around them. It could be shed supervisor trucks. It might even be buses going up Cottonwood Canyon, or maybe oil tankers coming across the highway. So we're looking at other ways of kind of getting a true reflection of what the road conditions are. And then I think you guys are pretty familiar with the website out there, UDOT Traffic Forecast View. Feel free to play around with that. There's a lot of new features. We're hopeful in the next 2 or 3 months we're going to be adding a lot more features, especially with the performance measure. There's going to be a lot of information there, so any questions at all how to read this information or how to navigate this page, just give us a ring at the weather desk. You know, Cody or myself or one of the forecasters can help you or guide you through it. But we do expect around February a pretty big upgrade to the website there. And I'm going to turn over to Kevin. I think Kevin's got a few last thoughts here.
So I told you I brought in the smart guys. That's pretty cool, huh? So what does this mean as an end game for UDOT maintenance, though? So where we have a real-time metric now where we can see what is actually happening on our roadways during a weather event. And we have also this year implemented AVL GPS units in all of our 500-plus plows. We are developing a process now where we can take this information and stream this information to our area supervisors, to our station supervisors, so that they have better information to make decisions off of. So if they've got trucks they know that are on a secondary route and this storm is predicting it's going to happen, come in this way, and they're losing, say, a major interstate corridor, they can see that now. They can redeploy resources. They can take care of things in real time compared to just us talking on the radio and what's it doing over there, and it's a visual perception. We actually have a numeric performance measure now that is going to give us better information for us to be able to do our job more efficiently and better in the future. There is one other piece to this that we're working on as well, and we are using a GIS-based system through a company called Spatial Matters that is actually going to optimize our snowplow routes for us. So we're working on that. We had an initial run with some initial data. We're actually taking our AVL data this winter for actual round trip times for our plows. You're going to plug that into the model and see what that tells us. So by reducing deadhead time on our plow routes, we'll probably even be able to potentially even reduce the size of our fleet and still maintain a better system. Potentially. I'm not saying we're getting rid of trucks. Don't freak out. But by taking these three things together, this is going to take us to a completely different realm of snow removal than we've ever been before in the past. And also, this puts us basically in the lead in the nation of being able to perform during a winter event and really understand what is actually happening out there. My hat's off to these two gentlemen. Couldn't have done without them. They're definitely the smart guys. So any questions? PJ. It's, as far as being able to look at the winter index, it's there now. You can go on the weather page and there's a click on it right now. The performance measure itself is in development as far as the web page, that information being developed. I think probably February it'll be available sometime.
Yeah, and I forgot to mention those were hand done, those charts.
Yeah, those were all concepts, and so we're still in the development phase as far as the stuff you're going to see. But again, this is pretty cool. Pretty cool. Yes. Yeah.
That's actually.
And you know what's funny? And Pat, and when I presented this to Carlos, and I told him how we had implemented the filter that took the red out, he's like, "Why are you doing that?" And I said, "Well, we want to paint a clear picture here of what our capability is." And he's like, "Red's not bad." And even using the terminology acceptable, unacceptable is not bad. Now, granted, we can change whatever we want this to say. What is the reality, though? If we're in a situation where we have low snowfall and we got snow-packed roads, is that acceptable? No, it's not. Let's be honest with ourselves. It's not acceptable. We should be able to be in a better situation in that condition. Let's not take it personal. This is business. It's a way for us to look at data, for us to look at how the actual system is. And if something is showing unacceptable, that's a learning opportunity for us. Okay, let's look at the data. Why did that happen? Why were we not able to maintain that system with our current force when the snowfall rate was only half an inch an hour and we had prevalent hard-packed snow on the roadway? Why did it happen? Let's take a learning lesson from that. What do we need to do? Is it different resources, different materials, different equipment, etc.? Mr. Barrett, you're laughing at me. Yes. And that's a good question. The question was, so if we put this information out there and it shows our performance during that time frame is unacceptable, does that create liability for the department? And the answer is no, it doesn't. We are actually protected by code against that happening. But again, I view this as it boils down to what was part of Carlos's main message over the last 2 years with the department: transparency. Let's tell the picture. Let's tell them the truth. What is going on out there? If we have not done something correctly, let's own up to it. Let's fix it. Let's not try to hide anything. Gordy? Gordy's question was, will this eventually eliminate the snow logs? Hopefully, yes. I mean, right now, we still want to continue that because really this year, with the information we're getting, we're really kind of just in a testing mode. What is it telling us? I mean, we're going to mine data for the next 6 months of what is this really telling us right now? What is the AVL system we're implementing telling us right now? How do we integrate these two pieces better? Is this going to look probably a little different next year? Yeah, most likely. Eventually, it is the intent to get away with anything that is perceptive. This, by us looking at it with our eye, even the 1 hour after the storm type of thing. Really want to move away from that eventually in the future if we can. And now, and Jeff did make one comment. It is the intent to have maybe potentially 1 ROS station in each station boundary. Is that probably going to happen? I don't know. It might, but it might not. But that's okay. Because the next phase we're looking at here with our current ROS, where they are, the next piece would be, where is it that the weather group needs additional instrumentation to be able to predict weather better for us? And let's put new stations there. Let's grow our network there. The last piece of this is, where do we need it now to grow out this network to be able to finish our performance metric and our performance measure? I honestly think, and Jeff's onto something here too, the mobile piece of this, if we can verify and vet the data that having mobile units like these on vehicles can fill in those gaps, you could have 1,000 units out there. We could employ the public to send data to us to let us know how we're doing. That's cool. We could even make them buy them maybe. I don't know. Doubt it. What else, guys? Again, I want to thank these two. The award, I'm going to say it again. The award that we won, UDOT won for this. You had some of the biggest companies in the nation that had put in for this award. Ford, GM, Apple, huge companies. And here we are, little UDOT, two guys developed this, and we won. That's staggering. That is so cool. My hat's off to them. Go to lunch. Thank you. You're welcome, PJ.